Hello, my name is Erica Woods, and this week we did Experiment 9 Atomic Mass. And for atomic mass, it means um, the atomic mass of an atom is found by comparing its mass to a standard mass. We ended up using the element benium, and so we used 3 different beans that we needed to find the isotope of each one. And the beans were black-eyed peas, pinto, and navy. In that one isotope, there were 351 beans in the bag. So in order to do the isotope breakdown, there were 94 navy beans, there were 117 pinto beans, and there were 140 black-eyed beans. We ended up measuring the mass of each sample. So for the navy beans, it was 30 grams. For the pinto, it was 21.5 grams. And for the black-eyed peas, it was 31.5 grams. And in order to get the atomic masses off of each one, give me 1 second. We had to divide the mass of the sample against the number of beans. So for example, 30 grams of mass for the navy beans divided by the total amount, which was 94 navy beans, gave us the atomic mass of 0.39. And we did the same for the pinto beans. We divided the mass of the pinto beans, which was 21.5 grams, over the amount of the pinto beans, 117, and that gave us the atomic mass of 0.183, and so on. Then we needed to continue to go on and get the percent of abundance. And in order to get the percent of abundance, we needed to divide the number of isotopes over the number of atoms. So we had to convert it into percentages. And with the navy beans, for example, we got 27%. The pinto was 33%. The black-eyed beans was 40%. And then when we added all of those together, the percentages, we ended up getting 0.236. So let me give you more of a breakdown where, give me one moment, I'm sorry. So for example, like question 1, what is the basic atomic difference between, no, it's not. Let me go to number 2 first, and then I'll go back to number 1. If there are 100 navy beans, 27 pinto beans, and 173 black-eyed peas in a container, what is the percent composition of the container by bean? So for the navy beans, we said 100, and we would take we would total all of those beans together. So with the navy, pinto, and black-eyed peas, just like we did in the experiment, that total was 300. Remember, previously, the total of my beans in my experiment was 351. So with question number 2, let me slow down. Being that the total was 300, we would take the total amount of navy beans, which was 100, divide that over 300, and that would give us the 33%. So that would be the percent composition of the container for the navy beans. For the pinto, it was 27. We would do the same thing. 27 divided by 300, which would be 27 over 300, gives us 9%. For the black-eyed peas, it was a total of 173, like question number 2 said. We would divide that over 300, and that would give us 58%. And for question number 1, what is the basic atomic difference between isotopes of the same element? Dr. Hinton definitely helped me with this. And so the answer to that is the number of newtons in the nucleus. Thank you, Dr. Hinton. For number 3, if your physical science grade is broken down so that 70% of it is based on tests, 20% is based on laboratory reports, and 10% is based on homework, and your average scores out of 100 points in each area are test is 85, your labs are 75, and your homework grade is 96, what would be your weighted average? So we would take the percentages that I gave, which would be 70%, 20%, and 10%. We want to turn those into decimal form first off, okay? So for example, the science grade is 70%. We want to turn that into 0.7. So we would take and I'm sorry, not the homework. The 70% is based on your test grade. So it's 0.7. So it says that the test average score was 85. So we would take 85 times 0.7, and that would give us 59.5. That would be the weighted average. Then for the lab reports, which in the problem is saying 20%, we want to turn that into decimal form. So that would be 0.2. And it says that, I just want to make sure I'm giving you all the correct information, that the average lab score is 75. So we say 75 times 0.2, and that is 15. So 15 is the weighted average. And then lastly, for homework, the percentage of homework is 10%. We would turn that into 0.1. And the average score is 96. So we would say 96 times 0.1 equals 96. Now, when we add those all together, we get 84.1. So our weighted average would be 84.1. And then the last question again, did you have any difficulties during this lab? I didn't. I did have a question with the number 1, but after speaking with Dr. Hinton, the question to number 2 is pretty much everything that we did in the lab experiment. So I enjoyed it. I enjoyed learning about the isotopes. I enjoyed the experiment. Overall, separating the beans, finding out the mass, weighing them, coming up with the atomic masses for each one. That was something new to me. The percent of abundance was new to me. But overall, with the instructions, with the help of my group member and the help of Dr. Hinton, overall, I would give this an experiment. It's kind of pretty good. 2 thumbs up. So thank you, and see you guys Tuesday. Goodbye.